Hi, my name is Claire Adams, and today I'm going to tell you about how we scaled Cron at Slack. So as I said, my name is Claire Adams. I use she, her pronouns. I'm a software engineer at Slack. When I worked on this project, I was working on an asynchronous compute platform on an infrastructure team. And since this is the Monster Scale Summit, the scale we were working with was about 10 billion executions a day. I now work on Search AI, and I live in New York. So this presentation is about how we transform Slack's cron system from a single node into a high-scale distributed system to meet increasing load demands and improve reliability and maintainability. Today we're going to go through what is cron, how do we use cron at Slack, what our scale is, and then what our original setup was and what our new setup is, and then some alternatives we considered, and then the impact and the takeaways. So what is cron? Cron is a command line utility used to schedule scripts or jobs. It's very commonly used for maintenance and administration tasks. It's an industry standard in executing things on a schedule. So what does cron do at Slack? Cron is responsible for a lot of critical Slack functionality, including things related to product and infrastructure. For product, we have Slack reminders, email notifications, status cleanup, schedule send, pretty much all these product features where things are happening at a schedule, and you really need to make sure that they're happening, regularly. Like you need to make sure your reminder's going off. If your reminder's not going off, you lose trust in Slack. So it's really important that we have these crons for those features. And then also we use the crons for your more routine maintenance, like the database cleaning, the analytics, things like that, things that happen, every day, every month. We need to automate somehow. So the scale we're talking about, Slack has about 39 million daily active users. I think it was 38.8 if you want to be more precise. But it's a lot of people who are using Slack every day and depending on it to work and work well. So we need to make sure we have a reliable system to deliver consistent, good experiences to users. Our scale is about 385 cron scripts, and these scripts run about 2,000 times an hour, which equals out to about 20 million times a year. So tons of executions, really high scale, really need to make sure these scripts can run and run without issues. So our legacy architecture for the first 10 years of Slack, there was one server running on AWS with one cron tab. And this cron tab lists out every single script we have, and the scripts were run locally on that server. So as we got more scripts, as we got more users, as they need more memory, we just would go and buy, the next bigger server, all that. So it was really just like this one box doing so much critical work. It had some big issues. When it was a security patch time, one engineer was responsible for getting the new box ready and then very quickly switching the old box to the new box so we don't get repeat runs, so we don't miss jobs. It was a stressful task to have, to be that person who's switching. But, it did work. It did work for a long time. What kind of led to this re-architecture was that we had 11 incidents in the year before, and people were really fed up with dealing with this one cron box. Nobody really wanted to maintain it. It had been set up a long time ago. People really had some legacy knowledge, but nobody really had total knowledge on all the quirky stuff with it. People were tired and fed up, and we needed something more reliable. We can't have 11 incidents that might impact users' ability to get their reminders. We need to be more reliable and more stable as a product. So that led us to this rewrite. This is my diagram of our original system. It was just this one box on AWS running the scripts on it. So our new architecture, so we created a high-scale distributed system for scheduling the jobs, and our main goals are around stability, providing reliable uptime, and decreasing maintenance burden. People were tired. The components we used where we leveraged this existing job execution service. So that's the asynchronous compute platform I mentioned that I was working on at the beginning that does billions of jobs every day. So it has a high scale already, and it is a really good system. The system didn't have a scheduling component, which is huge for Cron. Cron is all about scheduling. So we built an Orchestrator Scheduling service, and then we built a database for tracking the runs. Really wanted to get more visibility, make it easier, make people on call have an easier time. So this is the new architecture. We have our orchestrator service, we have our job queue, and then we have our database, and they're all in communication with each other. So to dive in, our orchestrator scheduling service is a Golang service on Kubernetes. We were already using Golang and Kubernetes for infrastructure, so it made a lot of sense to reuse them for this new orchestrator service. Right? Like, we're trying to decrease maintenance burden, so using the technologies we already have was a really key part of this project. The Golang has a really nice library for Cron, so it was really easy to reuse that library. There were ideas of making our own kind of timer service, doing it ourselves, like spinning something custom, but really like reusing that library and making sure the orchestrator itself is reliable made it super easy to do the migration. We don't have to rewrite the scripts. We don't have to have people, take their scripts and write them in a different language, do any of that. It was like 385 approximately scripts. That's across many teams, and the scripts are not owned. Migrating would have been too much work. So we wanted to just leverage what we have, make it really simple for people to switch to this new system, really seamless, so they don't even need to know. And then to make this orchestrator helpful and more reliable than just having our one cron box, we implemented leader election with locking, which I'll go into on the next slide. So for the leader election with locking, this was a really critical architecture decision. We had a crossroads kind of deciding, do we want to spread the scripts across many pods and say, like, some pods do the first couple, some do the next couple, like kind of do it like that and make it very distributed. Or we could have this one leader who does the executing. And we decided to pick this one leader because synchronizing between many pods seemed like a big headache. Network problems, anything like that really makes it more difficult. And because we were using this job queue system, we could offload the memory and CPU intensive work to that job queue system. So whereas before we had one pod that had to be huge so it could run everything locally, we can now just have one leader that all it does is send things to this other service. So it's just a couple of lines of code, and it really makes it much simpler and easier to maintain and understand. So this existing job queue execution service leverages Slack's job queue, which is the asynchronous compute system. It really consists of multiple queues, and it's designed with Kafka, Redis, and these job worker EC2 nodes. So how it works is you have like a Kafka instance, like a Kafka topic, and you send your job to a specific Kafka topic, and then there's that like keeps the queuing part of it. And then when it's time to execute the job, we move the job from Kafka to Redis so that we can do like bookkeeping while the job is running. Some jobs run for long periods of time, like weeks even. So it's important to have them in Redis in case anything happens. And then we have a job worker EC2 instance that does the actual executing of the job. And this, queue system, which is really like a set of many queues, is processing about 10 billion jobs a day. So adding our cron jobs was like very doable. There's tons of room in 10 billion for our work. So it was like very easy to get the scale we needed with it. And it was also really nice because we already had invested years into making this job queue system very reliable, very scalable, have good guarantees, and have a good on-call rotation and good maintenance. And there's a whole team working on keeping this together. So if we can just leverage that, that makes our lives a ton easier. We don't have to add new on-call. We don't have to add new systems or complexity. We can just use what we have. So this job execution service uses like a different format than the scripts we were running. However, we are able to write a job that just basically wraps each script, like reads it from a config and then wraps it and then executes it. So it's like each script is a job, but we didn't have to actually rewrite each script as a job, right? Because we're trying to make the migration burden like less. It's hard to get people to migrate their scripts. Some scripts are unowned. Nobody wants to do that. We did isolate all our scripts to their own queue. So it's a queue for all the cron scripts so that we don't have to deal with any interference with other jobs or like had to consider that. And as I said, it doesn't add any maintenance or on-call burden. The system is already staffed. So our last component was to add a database for job tracking. The new system used this database because we really wanted to know how the jobs are doing. We wanted more insight. People on call were fed up of trying to look at all the logs on this one cron box. They wanted a centralized area. They wanted a web page they can go to and make it really easy to know, like, did this job fail? Did this job succeed? When was the last time it ran? What's going on? And it really makes it easier to have this database and just like keep it updated, and makes people much happier to use the system. So in summary, we went from our single cron box, our one node running on EC2, and now we have our orchestrator service, our job queue, and our database working in tandem, which gets us much more scale, much more reliability, and helps really decrease the amount of burden. So even though it is more components, it is easier to maintain. So when I first started talking to people about this project, it came up a lot, like, why not use other alternatives, specifically like kube cron jobs? We had already invested in Kubernetes, so it seems logical to want to use the kube cron jobs. I think really it came down because of the scale we're working at. Slack has so many users, it has so many scripts running all the time. Like if we were to use kube cron jobs, we'd be spinning up 54,000 pods a day, because every time you run a script, it spins up a new pod. And that's like huge number of pods to have to manage. Things go wrong, the cluster is too big, one pod accidentally consumes too much memory. If they spin up or spin down too quickly, then we'd have to invest in better tooling, ongoing maintenance. It's like a whole new area to learn about. And really, we wanted to use what we had and what we already have the knowledge about and what we already have teams on to maintain. And we also wanted to consider the migration effort and like having to rewrite jobs and reconfigure things. So it really made a lot of sense for us to use the technologies we had already invested in, but it definitely is super fair to want to use kube cron jobs, and they do work quite well. It just wasn't right for our situation. So how are things now? We completed this migration a little over a year ago, and since then about 6 million cron jobs have run successfully. And this has really decreased our on-call burden. When we first did this project, we picked a database that wasn't that stable. So we had some issues with our job tracking. But since we switched our database to one that's better maintained, we haven't had any incidents, which is huge. It's like hard to quantify what's not happening, but to not have to be dealing with this like major blow up 11 times a year or whenever it's going to happen is really, really nice. So the takeaway is, one big takeaway that we learned is to use what we have. So we use our job queue, we use Kubernetes, we use Golang. It decreases the maintenance burden and we get huge scale ones. We had already made lots of investments in the job queue. We already had some Kubernetes, Golang going. It really helps a lot to just use what people already know. People don't have to learn something new when they go on call or when they join the team. We can just use what we already have. And I think an undersold takeaway is to keep it simple. Slack ran key functionality, like your reminders, you need them with cron scripts for 10 years on one node. Like that's a long time to be like, we're going to deal with this kind of less than ideal system, but it's good enough. It's okay. It gets the job done. And I think that is like a really key takeaway of like, it's okay to keep it really simple, even if it's kind of janky for a long time. And then, when you're fed up, you can try something better. Yeah, so stay in touch. This is my contact information. Thanks for watching.